Hello everyone, we're going to have a quick go at task 1 isPrime. So I'll click on here now. I'd like to thank a certain person for spotting an error that I made before. Excellent. So here we've got a class main. We mustn't change the name of these things, and the problem, it says create a public static method called isPrime, which takes an integer as its only parameter, and it will return true if the numbers are prime and false if it's not. And we should test that with suitable values like 9. So here I'm just going to go down there and I'm going to have a public method, so public static, and it will return a boolean, and it's going to be called isPrime. It will take an integer. I've called it integer n. I've pressed curly bracket, pressed enter, and I've got that. So I've got that stuff on the go there. If you don't have it like that, it won't work. So prime number, identifying prime numbers. So okay, and here I just start coming out with some ideas like, well, okay, if the number is, and I saw someone writing, if the number is 1, then it's not a prime, so return false. Yeah, that kind of makes sense. Okay, I suppose here we could have said if the number is less than 2. And that would have included 1 and 0. Okay. If n is 2, then I'm going to return true. You might think, no, I won't do that. And if you Google this, you'd find some really cool mathematical way of doing this. That's not really the point of this. What we're trying to do here is try to work things out nicely. Okay. And I've got some basic statements at the top here, so make sure I comment these. The next one I kind of want to do is I want to get rid of all the other even numbers. Okay, so what I want to say here, if n modulo 2, when you divide n by 2, if it's equal to 0, so if it has no remainder, that's the test for an even number, then it's false, because there's only one number which is divisible by 2 that is a prime number, and that's the number 2 itself. So I think that makes sense. And that way I've gotten rid of all the 2's. I'm not going to be testing the 2's, because otherwise you'd have a for loop that would be testing all the 2's as well. It would be testing 4, 6, 8 and all that kind of stuff. And that'd be a real waste of time. But this is just one way of doing it. So I'm going to iterate through the odd numbers. Okay, and how am I going to do that? I'm going to do for integer I is equal to 3, so I'm going to start at 3 because I've dealt with everything else before that. Here comes the interesting part. So I is less than, and I watched somebody doing something like that. I is less than that, and here I'll go I I plus equals 2, because I'm going to go up in steps of 2. Okay, and I'm going to do it like that. And then I'm going to go if n modulo I is equal to 0, so that's the test. If we can divide straight into it, then it's not a prime. Okay, so we have to return false. So here, if the number was something like, okay, if the number was 9, then it would go for integer I is 3 up to whatever that works out to be. If n divided by 3, so if 9 divided by 3, that's 3 remainder 0, then return false. Okay, and that kind of works. If it does get out of that for loop, then we have to return true, because we've found a prime number. I'm going to test that straight away. I'm going to test it with 9, and that should be false. That should return false. I'm going to test it with 11, and that should return true. I would test it with 1, false, and that is false. Test it with 2, for the sake of it, I'll test it with 4, then I'll test it with 17. Test it with 17. And 17 should be true. Yeah, and 17 is true. So for 17, it did this if statement, this if statement, this if statement. It didn't get to any of these returns. It went through here, and it went from I is 3 to I is less than 17 divided by 2, okay, which resolves to 8. Okay, I is less, so it went up to 7. So it tested for 3. So 17 divided by 3, divided by 4, divided by 5, divided by 6. Okay. However, in fact, sorry, divided by 7 as well. However, some of that is wasteful because here, this part really should be the square root of the n value. Okay, so so here we'll do math.pow, and this is where I made a mistake last time, and I wrote -2 and it should be 0.5, and that's the square root function there. And we'll go +1, and I'm going to cast that to an integer. Okay, and if you have a look at that, and hopefully you'll see that that is a little bit more economic. Okay, I'm going to run the test to see if that works, and that one works fine. I did a lot of tests for that one, and then I'm going to submit that. And so that's great, completed that. We can look at the model solution, which hopefully now has got the correct answers in it. And yeah, I've done that the same way here. That was where the mistake was before, but I've fixed it now. Nice and easy. You can see I've done single line if statements here. I've not done brackets because you would be accustomed to doing that. And if you do want to do that, that's fine. I'm happy with that. It's just that if it only has one statement, it can be in the same area. Okay, like that. There's other ways to do isPrime. There's better ways to do isPrime, and you can Google them yourself and see if we can find a better solution, a nice solution. But this is one that we can work out by ourselves. If you were doing something like HackerRank tasks, this wouldn't be good enough. Okay, because it's timed. Anyway, that's that first one. Hopefully you can get that one done by yourself now. Comment up a little bit better than this, and then have a go at the next one, some primes and so on. Okay, cheers, catch you later.